All right, this is just a reminder, refresh, review of what we learned and what we saw in the lab. What we saw is the IBGP address means when IBGP advertises a network, the next hop address that is advertised by EBGP is carried into IBGP. This part we are very
Yes.
clear.
Yes.
But if that next hop is unreachable, then we need to say next hop self. For example, in here, router C will receive these network with this address as the next hop. For C, it's an unreachable address. So C will see the BGP update, but C cannot use it. For that, what we do is we tell to B to say next hop self, next hop self, so that C will have B's address as the next hop. And also we learned that whenever you have this type of topology where A, B, and C is in same subnet, you see a layer 2 switch here. 10, 10, 10, 1, 10, 10, 10, 2, 10, 10, 10, 3. A can reach this network and this network directly via C, even though C is not a neighbor with A. C is neighbor with B and B is neighbor with A. EBGP with A, IBGP with C. So BGP updates are actually coming from D to C and takes the C's network and come to D and come to B, and B only gives the update BGP update to A. A learns about this network from B, but with the next hop C. Yes, that is how BGP is designed. If if router B is going to give to a neighbor which is in same subnet, if router B is going to give to a neighbor who is in same subnet, the updates that I've got the next hop also same subnet, then B should not put its own address, it should simply carry C's address to A. That's the logic. So let me put it in another way. If you didn't understand what I say, if you see this one, this is plain and simple. BGP is efficient by informing this 520 about the best entry point to reach 172.30.10.00. So best entry point is this way. And we saw this in the lab as well.
Yes.
Let us move on to the next topic. Next topic is a kind of template that we create whenever we got a common configuration or same configuration or same outbound policies for many neighbor. I repeat, this topic is called as peer group. This peer group is used to create a template. Why do I need template? So that I can use it repeatedly with many neighbors with whom I have same outbound policy.
Right. Well, I think I read something said they stop use peer group and start use something named peer template or something like that.
See, peer group, peer template, all are same. iOS router command is peer group. Command is peer group. But I think iOS XR has got peer template.
Okay.
Basically, command is different, but concept is same.
Okay.
Concept is same. Peer template, peer group. All right. So whatever the command may be, if you read, if you just pronounce the word peer template, you will understand it. They are talking about peer group. So don't get confused. Both are
Okay.
same. Now you see, um, when do we use this? Very important. When do we use this? Whenever we have same outbound policy to be configured to many IBGP neighbors. Mostly we use this in IBGP neighbor. But I'm not saying that you should not use between EBGP. Between multiple EBGPs, we may not have common policy. And we will not have outbound policy. EBGP, will you have outbound policy? No. With IBGP only, we'll have common outbound policy. But peer group can be used with both EBGP and IBGP, but where it is more relevant is only IBGP. If you find any reason to use, if you find any genuine reason to use this in EBGP, definitely it will help you. Because I saw one CCIE question in 1 year. I don't know exactly which year, but definitely it is before 2019. The template was created between EBGP neighbors and used between EBGP neighbors. But that's a very rare case. But mostly you will have common policy, outbound policy only between IBGP neighbors. Let's see these lines. This command defines a template with a parameter set for group of neighbors instead of individual. Okay. So whenever you want to form neighbor, an individual neighbor, you don't need template. Whenever you have many neighbors with same outbound policy, you need this peer group. See, members can have different inbound policy, that doesn't matter, but outbound policy is same. Members may have different inbound policy. Peer group we are not going to use for inbound policy. As usual, the inbound policies can have variations, no problem. But if the outbound policy is same for all IBGP neighbor, you can use this peer group.
Right.
What is the advantage? Advantage is the last two lines. Updates are generated once per peer group. What does that mean? For example, I want to create, let's say we are going to an orphanage and we want to distribute eraser, pencil, a pen, a geometry box, maybe a pack of sweets, and that's all. Let's say these things we want to give to children in the orphanage, and we also got some more things like a briefcase. A briefcase. You know what is briefcase?
Yes, yes.
Okay, you use the word. Okay, fine. You want to give a briefcase. You want to give a watch. You want to give a cell phone to the employees of the orphanage. Now, instead of saying child one, give eraser, give pencil, give pen, give box, instead of saying like this for every child, what I can do is I can put all this in one template called for child or for children. And this one I'll put it in one template called for staff. Now what I need to do is simply C1 means child 1, give this. Child 2, give for child box. Now we put this in a box. C3, give for child. S1, what I will give? For staff. When I say for staff, I no need to say these things separately, you understand?
Yes.
For staff word means briefcase, cell phone and watch. When I say for child, it means eraser, pencil, pen, box and switch. It is easy for us to map. So it is just one time processing. That is what here it means. Updates are generated once. Just you give this one box of this material, you have already given all of them. Instead of you give one by one, just put it in one box, give it. Your job will be done easily. You understand what I'm saying? When you give eraser, the child is coming. And then again you call the child and give pencil. Again you call the child, give the box. That wouldn't be nice. That is multiple time processing. You understand what I'm saying?
Yes, sir, I understand.
We put all the configuration in one box and we process it just in one go. For example, instead of saying this IP address neighbor belong to this autonomous system, this IP address neighbor update total bug 0, this IP address neighbor, next option, this IP address neighbor. See, for one neighbor you have processed 4 times. And again, same commands, you see this and this are same. This and this are same. Repeatedly you need to type for many neighbors. So line of code is also increasing. To avoid that, we create those 4 lines in a template called internal. Any name you can give, internal or inter or robot or anything. To identify the peer group, you can give any name. This looks like a command. This is not a command. That's what I mean. You got me? You understood what I say? And then you go and call the name here with the neighbor. Just in single process, all this gets processed for the neighbor. Single process. That's what this command. Second last time you say. You see, updates are generated once per peer group. Just once. Not separate. Single process. That's what I mean. Single process. And the configuration is also simplified. You see, instead of repeatedly typing 3 times same thing in this example, you just 3 times processing. That's all. Here 12 lines of process and 12 lines you need to type. This is very simplified. You got it? All right. Now about the network command, you know already. If you are advertising a classful network, you no need to use mask. You can type without mask. If you are advertising a classful network. If not, you need to use the mask option. You see, you need to use the mask command. And the mask that you type should match with the route in the routing table. Got it?
Right. Yes, sir.
All right, like this. If you have a route like /16 already in your routing table, maybe you have a summarized route like this, then you should use this mask. This is class full. You no need to type this. This is a mistake they have done. No need to type. All right. Next is the synchronization rule. This rule is no more needed. Why? Because it's off by default now. It's no more needed. That's why they have offed it. They have offed it because it's no more needed. But it is good to know what this rule is in case if someone asks, we can answer them. Are you ready to learn this now?
Yes.
I'll take you to an example and then I'll read this line, okay? If I read this now, you will not understand. I'll take it to an example.
Okay.
You see, F is advertising this network to B. F is advertising this network to B, 172.16. And B is giving it to A because it's an IBGP neighbor,
Right.
C and D. If synchronization rule is on, A, C and D should not use what B has given. Should not use. Neither use nor advertise to anyone. As a result, E will never learn about this network. You got my point?
Right.
E will never hear about this network because the rule says, synchronization rule says, whatever B gives to D, C and A, they are not supposed to use until they receive the same network matching via OSPF. This is not really useful. Why will OSPF also run the same network coming from outside? Understand one thing.
Sir.
BGP we are using to bring the external network. If OSPF will also bring the external network, then what is the use of BGP?
Right.
Initially, someone made this mistake. They thought that if OSPF also say the same network, only then it is safe, secure. Otherwise, we should not use it. How can we allow BGP to simply advertise something in our network? We should also check whether OSPF uses the same network. Otherwise, it's useless. Okay. Now let me read these lines for you. Synchronization rule says do not use or advertise to an external neighbor a route learned by IBGP. Means you learn from B router, IBGP,
Right.
until matching route has been learned from OSPF, IGP. Got it? So this is a
Yes.
useless rule. So they have offed it by default. When you type running show running configuration, in some running configuration you can see it is already typed no synchronization. It's already
Right.
typed. Even if you don't care about it, nowadays no operating system has got the synchronization rule on. It is off. But if you want to on it for some reason, you can on it by typing synchronization. Okay.
Yes, sir.
Did you understand this topic? BGP
Yes, I
synchronization.
do. Yes.
Okay. All right, this is just a configuration example. Next, BGP states BGP messages are different. We learned earlier in another earlier class. We have BGP open message, we have keep alive message, notification message, and then update. You remember? Open message, keep alive message,
Yes, sir.
update message, and notification. You remember, no?
I remember, but if somebody asked me to explain them, I cannot explain them, but I remember them.
Okay, I'll explain you. Open message is sent as the first packet with the BGP router ID to the neighbor along with the timer.
Right.
Keep alive is sent every 60 seconds to make sure neighbors are alive, available.
Okay.
Notification is sent whenever there is an error in the path, BGP path. And the last one is update. Updates are sent whenever there is a change in the attribute. See, error and attribute change is different. Whenever there is an error, it is notification. Whenever there is a change in the attribute, it is update.
Update.
Those are message types. This is BGP states. While forming neighbor, no, the neighborship comes established only after the 5 states. Like we learned in OSPF, you remember init state, two-way state, extart state, exchange state, loading state, full state, down state. You remember that?
Right.
Likewise, in BGP you have idle state. What does that mean? Router is looking into the routing table to see where the neighbor is located. Because it's TCP based, no, it needs IP path.
Right.
Now, once the route is found, it will do three-way handshake. See, route is found and it is doing three-way handshake and it got completed. That is what called as connect state. Once the three-way handshake is over, the open message will be sent to the neighbor, and if the neighbor is receiving the open sent message, then the neighbor will confirm by saying I'm ready to establish, and it will go to establish. But if there is
Wait, but no, go ahead. I was asking about that active.
That's what I'm coming. See, listen. Open message is sent. I'm saying, hello, Robert. I want to form neighbor with you, and you are saying, okay, I can see you are using TCP 179. I receive your conversation that I received your request, but unfortunately, I am not ready now to do BGP neighbor because I'm not configured. Goes to active state. If both the side they are ready to do the conversation, they are ready for BGP, then it goes to the established state. Otherwise, the open confirm will reset and go back to idle state. It will start again from here. See, if any one of this neighbor parameter doesn't match, even if you make a wrong IP address of the neighbor, when you say neighbor, you gave wrong IP address. It will come up to open confirm, but open confirm will not go to established state because the parameter doesn't match.
Right.
So it will again start from idle, keep trying. And when you fix the issue, only then it will say established. Yeah?
Okay.
Any question?
No.
All right. See here, this explains when you will have idle state. It will be staying in idle state for a long time if you don't have route in the routing table, right? When you want to see whether it is established or not, what command I use to check the neighbor? I type show IPBGP summary, right? isn't it?
Yes.
When I say show IPBGP summary, what I'm expecting is in that prefix received, I expect some number, either 0 or something. I don't want to
Yeah,
see
but I can type also show IP BGP neighbor and the neighbor address, and you should see establish.
that is different. That is a big page. See, when you type show IPBGP summary, easily you can see all the neighbor in one page.
Right,
And when
right,
you see
right,
here some number, it means neighbor already established and you learned some networks. This is more
right,
friendly than typing this command. You understand?
right.
This command for each neighbor, it is going to show you pages of information. You will not know in
That's true.
one glance. You will not know the status of all neighbor in one page.
No.
All right. So that's it. So active state, when it will go, because the parameters don't match, it jumps between idle to active. See here, they are mentioning the reasons. The neighbor does not have the root. Sometimes you send the packet, the neighbor receive, but neighbor don't know how to come back. There is no root.
Okay.
Second is you have given wrong neighbor IP address, or sometimes the autonomous system itself is a wrong autonomous
It's
system.
configured.
Neighbor does not have neighbor statement. Sometimes one router is configured, the other router is not configured.
Right,
If any one of this is there, you will see active state. Now, whenever you
right.
make mistake in the autonomous system number or IP address, it will show you like this. You remember yesterday I made a mistake. It was showing wrong peering address. Now, when you make
Yes,
autonomous system
yes.
mistake, it will show you peer in wrong AS. All right.
Okay.
All right. Okay. I think we'll start from here in the next class. Authentication.
Yeah,